Welcome to this comprehensive deep dive into server-side request forgery, commonly known as SSRF, and its particularly critical role in enabling attackers to pivot and gain access to sensitive internal systems within an organization's network. SSRF represents a serious security vulnerability that allows a malicious attacker to manipulate a server-side application into initiating HTTP requests to arbitrary domains specified by the attacker, potentially exposing internal resources. In essence, the vulnerable server unwittingly serves as a powerful proxy, transparently forwarding these crafted requests on behalf of the attacker to destinations they couldn't reach directly. This becomes especially dangerous in scenarios where the compromised server possesses privileged access to internal resources, such as private databases or services, that are carefully shielded from direct internet exposure through firewalls and segmentation. The true power and danger of SSRF truly shines in its capacity to facilitate pivoting, empowering attackers to perform lateral movement deep within an organization's internal network, jumping from one system to another. Picture this: an attacker successfully exploits an SSRF vulnerability in a public-facing web application that processes user-supplied URLs without proper validation. Rather than sticking to harmless external websites, the attacker cleverly crafts requests targeting internal IP addresses like 192.168, 1.1, or internal host names such as localhost or database, internal.company.com. Since these malicious requests originate from a highly trusted internal server, they effortlessly bypass perimeter firewalls, network access controls, and segmentation policies designed to protect the internal environment. This breakthrough grants the attacker unauthorized access to otherwise unreachable internal services, including proprietary APIs, sensitive databases, administrative panels, or even cloud metadata endpoints like those in AWS or Azure. A prime example is when an attacker queries the AWS EC2 instance metadata service at 169.254.169.254 to extract temporary IAM credentials, which are often used for automated processes. Armed with these stolen temporary credentials, the attacker can then impersonate the instance to access other AWS services, such as S3 buckets or RDS databases, thereby escalating privileges and solidifying their foothold in the cloud environment. Another frequent and lucrative target for SSRF exploitation includes internal administrative interfaces, which are commonly hosted on default ports like 8080 for web consoles or 9100 for printer management systems. By directing SSRF requests to these exposed interfaces, attackers can potentially log in, execute commands, or manipulate configurations, thereby seizing control over vital infrastructure components. The consequences of a successful SSRF pivoting attack are severe and far-reaching, spanning from stealthy data exfiltration of confidential information to complete compromise of entire systems and networks. Effectively defending against SSRF demands a robust, multi-layered security strategy that addresses both application and network levels comprehensively. Robust input validation stands as the first line of defense, meticulously ensuring that any user-supplied URLs, parameters, or host names do not resolve to internal IP ranges like 10.0.0.0/8, 172.16.00/12, or 192.168.0/16, nor sensitive host names. Additionally, enforcing strict network segmentation combined with precise firewall rules is essential to confine outbound connections from web servers, blocking access to internal ports and IPs by default. Shifting from unreliable block lists to proactive allow lists for only whitelist domains and protocols provides far superior security, as it inherently denies everything else by default. Lastly, maintaining a rigorous schedule for patching and updating all software components, including web servers, libraries, and dependencies, is vital to eliminate known SSRF vulnerabilities before exploitation. Mastering the intricacies of SSRF and its pivoting techniques is indispensable for security professionals, developers, and students aiming to architect resilient, secure systems in our increasingly complex and threat-laden digital landscape.